Hey folks, Mr. Dell here. We are looking at a situation where we need to determine whether we have parallel lines using the rules based on parallel lines cut by a transversal and what angles would be equal. So let's run through some of these ideas and examples here. This is from CPM. I'm taking this problem from CPM Course 3, and this is section 9.1.3. Specifically number 933. So the problem says, based on the given information, determine which pairs of lines, if any, are parallel. If none are necessarily parallel, write none. So the first letter here, A, gives us information about angle 2 and angle 7. So if we look at our diagram, angle 2 is here, angle 7 is here, 2 and 7. So if those are equal, would that determine any lines to be parallel? Well, if you look at this, those are equal. Those are on alternate sides of this line, which is a transversal because it cuts two lines. A transversal is a line that goes through two other lines. So these are alternate interior angles. And alternate interior angles, if they're equal, then that tells you that these two lines are parallel. The transversal, two angles on either side, alternate interior, they're on the inside of the parallel lines. Therefore, we would say that C and D are parallel. Okay, so what about excuse me, what about angle 3 and the measure of angle 11? They say measure angle 3 and 11 are equal. So here's 3, here's 11. So here you have a situation where there's two angles, and in this case, we're looking at this as my transversal, D is my transversal, and it's cutting F and E. So F and E is who it's going through. So this transversal goes through F and E, and we have 3 and 11 are considered corresponding angles. And when a transversal cuts two parallel lines, the corresponding angles are equal. So that is corresponding with that because it's the same location as it would be on either parallel lines, as the transversal being one side of the ray, one ray of the angle, and the parallel line being the other ray of the angle. So those are corresponding lines, and therefore that tells me that E and F are parallel. So we would say E and F are parallel. What about C? C says angle 1 and angle 12. So angle 1 is here. Angle 12 is here. So I need to know whether angle 1 and angle 12 are creating parallel lines. Well, angle 1 and angle 12, if we look, we've got really a situation where they're on either side of lines, but not on the same line. So they're on either side of these two lines. Plus, they're not even connected to a single line. So if you think about our situation, it's always two parallel lines and one transversal, and the angle is in relation to the single transversal along with in location with the parallel lines. Well, this angle 1 it doesn't share any of those aspects. It has two different rays that make that angle that are not even at all connected to the other the same line, right? So it's D and F, line D and F make angle 12, line C and E make angle 1. So there's no common ray, no line that creates a common, no rays that are in common with the same line. So that being said, we cannot determine. So we would say that there are none because of this. No, it doesn't give us any information about parallel lines. Angle 13 and 12. Here's 13, here's 12. So if you notice again, 13 and 12, as mentioned before, is there one of the rays that create those angles common with one of the lines, right? And yes, there is. So F here's line F and line C, and then here's line F and line D. So that gives us some hope that F is the transversal and C and D are parallel because those are equal. And why are they equal? You've got a couple reasons. One, you know that 12 and 15 are equal because 12 and 15 are equal because they're vertical lines. And then 13 and 15 are equal because 13 and 15 are corresponding angles. So what we really have here is this alternate exterior angles, 13 and 12 are, and those are equal. Therefore, that makes D and C parallel. So we would say C and D are parallel. Then last one, E, it says 6 and 7 are supplementary. Remember, supplementary means that they add up to be 180. Supplementary means that the angles add to be 180. So 6 and 7, we have a good situation because if we think about the ray that they share line E for their ray. So 6 is made up of C and E, and 7 is made up of D and E. So they have a common line, a common ray. So that would be the transversal, and they're being cut. The transversal cuts C and D, and we do have a postulate, a rule that says that same side interior angles are supplementary. When a transversal cuts two parallel lines, the same side, this is the same side, 6 and 7 are on the same side as the transversal, they're supplementary. Interior, same side interior angles are supplementary. So yes, that tells me that C and D are parallel. All right, I believe that's it. There you go.